Hi guys, my name is Stephen Petruzzo. I'm presenting on the state design pattern. This is for the University of Michigan at Dearborn CIS 566 class, Software Design Pattern Architecture. Introduction and intent of the state design pattern. The state design pattern is a behavioral pattern. It allows an object to alter its behavior when the internal state of an object is changed. That object will appear to change its class. This simplifies implementation as it encapsulates varying behaviors for the same object, and it provides a cleaner and more maintainable way to change the behavior of an object during runtime without using traditional conditional statements. The state design pattern and finite state machine are very similar to each other. Each node represents a different internal state of the object, and each edge of the finite state machine represents a valid transition from one state to the next. An example of that is at the bottom right of the screen. Motivation. The state design pattern is particularly useful when an object has multiple states with the option of adding additional states in the future, also deleting additional states in the future. It's very useful for that. The traditional methods using if, else, if, switch, or statements and switch statements of implementing state-specific behaviors directly within a class is inflexible and hard to maintain. This commits the class to use the original state and behavior, and you cannot add a new state or change the behavior of the class independently. When using a state design pattern, the state-specific classes are independent, therefore adding new states will not affect existing states. Objects can change their behavior on runtime depending on the current state. Consequences of the state design pattern. Some positives are that it allows the state of an object to change during runtime. This separates this separates the client interface and code from the state code, and increases maintainability. It's easily add more states in the future, and it also provides a cleaner, more readable implementation. Some negatives of the state design pattern is that it increases the number of classes. As you increase the states, as you need one concrete class per state. So if you have an object with a lot of different states, it increases the number of classes. Also, the implementation decentralizes the state implementation, meaning that the state subclasses have knowledge of one another. This can introduce implementation dependencies between subclasses, and this is because each subclass or each state has to know what states are valid to transition to. The structure of the state design pattern, here's the UML class diagram. At the bottom, we have the concrete states, concrete state A and concrete state B. This provides implementation for methods that are defined in the superclass, the state above it. The state or the superclass defines interfaces for declaring what each concrete state should do and know. And then the context to the left of it, the context defines the interface for the client to interact with. It maintains references to concrete state objects, which is used to define the current state of the object. Here's a sequence diagram of the state design pattern. The context is used by the client to transition to either state A or state B. State A and state B then define the behavior and state of the object that's being used in context. Application and uses. The state design pattern should be used when varying states of the object define the behavior of that same object. When the states of the object are complicated and complex, the state design pattern is extremely useful when a system contains a finite state machine, as we have previously seen, has a defined process, or can be represented in one independent state. Some examples of where this state design pattern could be useful in is MP3 player. There's different states that are pause, play, rewind, fast forward, skip, etc. Also an ATM machine with a welcome screen, insert card, state, enter PIN, dispense money, and also shipping a package. Shipping a package has a defined process, such as pack the package, ship it, package is in transit, it's delivered, and etc. So for this demonstration that I'm going to be demonstrating, it will be of a 5-speed manual transmission in a car, and you're allowed to shift either up or down by entering a 1 or a 2 in the program. The state of the transmission can change to the next or previous valid transmission gear. An example of that is presented here. So the default state is in park, and from park you can transition to reverse. Once you're in reverse, you can either go neutral or you can go back to park. In neutral, you can go to drive or you can go to reverse. But in park, you can only transition forward or shift up into reverse. You can't shift down as that is not a valid state. Here's a class diagram of the demonstration. The concrete classes below are park, reverse, neutral, drive, second gear, third gear, fourth gear, and fifth gear. The transmission base state is the base state here. that declares what each concrete class should do and know. To the left of that, we have the transmission context, which is what the user in the program is going to interact with to either transition the state up or transition the state down, which represents shifting up or shifting down the gears. Here's a basic sequence diagram of the demonstration. So the default and starting class is in park, or starting state is in park. Then the driver and user can shift up, which will transition the state from park to reverse. Then they can shift up again, transitioning from reverse to neutral. They shift up again from neutral to drive. And if they want to, they can shift down from drive to neutral. And again, they can shift up from neutral to drive and continue shifting up until they reach the top gear or the fifth gear. Here's the works cited page. And now onto the demonstration. So here is my base state header. Here's my base state. All the methods in here are pure virtual functions. And then here's all the concrete states. So here's park, reverse, neutral, drive, and goes all the way up until fifth. And each state or each concrete state here can print the state it's in, shift up to the next state, and shift down to the previous state, depending on what the user and context want to do. Here's implementation for this. And then here's my context header. So some public methods here are here's a constructor, here's a destructor, and here's what the client will call to shift up and shift down. And so here's the client code basically, or here's an example of the client code. If you enter 1, we transition up. If you enter 2, we transition down. If you can't, then invalid entry. So if we run this right here, so here you can see that we're in park. If you want to shift up, enter 1, shift down, enter 2. Let's shift up. Then we go to reverse, shift up again, neutral, drive. We can go all the way to fifth state here. If we try to shift up again from the fifth state, that's invalid. And it'll say you cannot shift to that state. Here you can shift down all the way to park. If we shift down from park, it's an invalid state, and it'll say that. Thank you.